All right, so this is our second section of trigonometric equations, and this is where I told you last time we could have run these two sections together. The difference that we're going to see happening in this section is evidenced by the first equation. What do you notice about this equation? It can be factored. We're going to see factoring coming up in this particular section, okay? So, I mean, we had a squared in the last section, but we were able to handle it with a square root because it was the only thing that was squared and there wasn't another x in the problem, and I don't have that here now. So I see something here that looks an awful lot like what you saw in algebra when you had x squared plus 2x plus 1 equals 0. Do you see the similarities? I mean, it's not x that's squared, and it's not x that's multiplied by 2. It's cosine x, but it has the same similarity kind of feel to it, the same properties. And just for a moment, let's factor the one that I have in red. How would x squared plus 2x plus 1 factor?
X plus 1. X plus 1.
It would. And the way you can make sure that that's correct, if you remember, is that the first two terms, x and x, have to multiply to give you the first term, x squared, which they do, right? The last two terms, 1 and 1, have to multiply to give you the last term, which is 1, and they do. And then when you check it on the inside, you get x, and on the outside terms, you get x, and x plus x is the 2x in the middle. Okay, so it's a factoring process. And there's other ways to factor or to think about it, but trial and error will probably suit you just fine on most of what we're going to do. So we're going to factor this one the same way, except that we don't have x, we have cosine of x. And I need cosine of x in each of the first two locations because I need to multiply cosine x times cosine x, and I need to be able to get cosine squared, which I do. And then the same thing with the plus 1s at the end. So when you did algebra, they called this a repeated zero or repeated root. Both of these are going to, because they match, they give you the same solution, right? I mean, I don't get anything different from either one of them. So in essence, what you typically do is you set them each equal to 0, but it's kind of overkill because they each are the same, right? I don't really need to solve them both. They solve the same way. So the first, what will I solve then? So I'm just going to pick this one right here at the beginning because they'll solve the same way. What do I do to solve cosine of x plus 1 equals 0? Subtract 1. So this is cosine of x equals negative 1, right? And then I'm back to the unit circle. On the unit circle, where does cosine equal negative 1? At pi, exactly. And, oops, I about to put pi over 2. And that is the only place where that happens. Okay? It's a quadrantal angle. Let's take a look at the second one. It's easier than the first. It's already in, I guess you could say, factored form. Because I don't have any addition and subtraction to unfactor, right? To factor, that is to unfoil. So sine squared x times cosine squared x equals 0 if either sine squared of x equals 0 or if cosine of x equals 0, squared of x equals 0, right? If either one were to equal 0, then it wouldn't matter what the other one was because 0 times anything is 0. It's called the zero property of multiplication. Right? Multiply by 0 and everything goes away. All right, so we have sine squared of x over here. How do I get rid of the squared? Square root, which is rather uninteresting in this particular problem because I'm square rooting the number 0. And what is the square root of 0? It's 0. So now I've got sine x equals 0 and I've got cosine of x equals 0. Is everybody with me? Okay, so now you use your unit circle and you think, where does sine of x equal 0? Zero and pi. Do we need to have a unit circle quiz again? Okay. Cosine of x. Where does cosine of x equal 0? I know a way that we could solve the problem. I could just tell you you're not allowed to put the unit circle on your note card. That probably would solve the problem. We'll think about that. All right, so this is it for problem number 2. Any question? We have 4 solutions on this one, don't we? We do. And it's possible to have 4 solutions because what I really have is sine x times plus times cosine x times cosine x. I actually have 4 terms here. So the 4 solutions is perfectly reasonable to have. In fact, it could have more because I'm dealing with trig, but this would work for now because those are all I have for 0 to 2 pi. All right, let's take a look at this one. So as I look at this one, what's different about this one? I have what? It doesn't equal 0. That's true. What else? Not quite. I do have a double angle in here, but is it all double angles? No. And that's sort of a problem, okay? In order to solve any of these, the angles have to match. So I don't care if I have double angles as long as they're all double angles, and these aren't, right? So I need to change them so that they all do match the same type of angle. I don't want any double angles, not because I don't like double angles, but because I need all the angles to match, and it's easier to take something that's a double angle and turn it into a single angle than the other direction. So I'm going to work on the left or on the right-hand side. Let me leave the left-hand side the same. Remember, this is not verifying or establishing identities, right? But you do have some formulas from when we worked on that that can be used. What is the cosine of 2 theta? You probably want to look it up because there are 3 options. I'm glad you said that, Eric, because that's important to realize. We need to pick the right one. And there is a right one. Which one is the most helpful in this situation? Why do I like that one and not the other 2? It doesn't have sine in it. I don't want sine and cosine in the same problem. All right, not when I'm solving an identity or I'm solving an equation. I need it to be one or the other so that I can do things like factor. Okay? So this identity of cosine 2 theta is the one that I want because it only has cosine in it. And then I can do very much like what problem number 1 started as, and I can get it to equal 0 because you guys already told me it doesn't. So we're going to move everything to the left-hand side. Okay? So I'm going to subtract 2 cosine squared of theta. And I'm going to add 1. Which leaves me with nothing on the right-hand side. On the left-hand side, don't get overzealous. You can't combine the cosine squared and the cosine. You're just going to write them down. So, in fact, just because I don't like negatives at the beginning, I'm going to put cosine first. Not because it matters, but because I'm weird. So here's what we have. Because the 1 and the negative 1, those add to 0, right? Everybody with me? Right. Now, the nicer thing about this one than the example number 1 is that I don't have 3 terms. I just have 2 terms. So how do you factor when you just have 2 terms? Yeah, you look for what they might have in common that you can factor out of them. And cosine will work. So I can take cosine theta out of each of these. If you take cosine theta out of cosine theta, do not mislead yourself to think that it leaves you with nothing. This is like division. That's what factoring is. It's a method for dividing. Okay? So when I divide out cosine by cosine, I get 1. And then I have minus 2 cosine theta left equals 0. And finally, I'm going to get something that's got different solutions that's not sort of odd looking like number 2. So I set each one of these individually equal to 0. I've already solved, and you've already solved, cosine of theta equals 0 today. So let's see if you remember it. Where does cosine of theta equal 0? So you either remembered it or you remembered how to find it much faster. Either way, we're making progress. Yes, pi over 2 and 3 pi over 2. The other ones require a little bit more work. I have to do what?
Subtract 1.
Subtract 1 and then divide by negative 2, actually. So if I subtract 1, I have negative 2 cosine theta equals negative 1. And if I divide then by negative 2, I have cosine of theta equals 1/2. Okay, so unit circle, cosine equals 1/2. Well, cosine is positive in which quadrants? 1 and 4. So you need to be looking in quadrants 1 and 4 in your unit circle for the cosine value, which is the x coordinate, to equal 1/2. Oh, good. It's either 6 or 3. Which one is it? It is pi over 3. So it's pi over 3 here, and then I got to get the one that's way down here. Okay, it's 5 pi over 3. 2 solutions. All right.